May 3rd, 2016. I don't mean to be a stickler about this, but I need to mention it. But as I noticed on the video that you showed me, we had a large rocky body, which was really hot, by the way. It was molten. And then you had another rocky body over here, and then there was another one over here, and they both slammed into this larger one, and then they made a bigger, little body. And then obviously the conclusions that they want to make are that process just continues on, and you have smaller rocky bodies slamming into the larger one. And this process in establishment is called accretion. There are a few problems with this. Problem number one: how did the rocks form to begin with? Okay. How did these form to begin with? Every single geologist on Earth knows that to form rocks and minerals, you need two things: high pressure and high heat. That's how you form diamonds. Rocks and minerals are the same thing. Diamonds are rocks. Literally, it's carbon. You also can call it a mineral if you want. But that's how rocks and minerals are formed, in high pressure and high heat. Where is this pressure? This is vacuum, okay? Where is the heat? What got this material hot to begin with to where it slammed into it as a molten structure? What heated this thing? This slamming into this, sure, it'll get hot a little bit, but for the most part, it's not going to get hot enough to melt and then stick together. We can falsify that very easily. We do that by watching ballistics, okay? If you have an object traveling at any velocity, basically in outer space, it's above the velocity of a rifle round, which would be around, 3,000 feet per second. Yeah, it'll melt, but what's going to happen is it's going to hit this object so hard that this is just going to slam apart. And instead of making one bigger body, what's going to happen is this big body is going to slam into a bunch of smaller bodies, and it's gonna disintegrate. If you'll notice in the illustration or in the graphics video on that, the body somehow is going really fast, and then it slams and it glues together to it as if there was some type of thing there, and it's like a big glob. But that's not exactly how it works. So you have a few problems here. How do the rocks and minerals form to begin with? Because when there's no pressure, it's vacuum, and there's no heat source as well. Let's see, what else? What else can I add to that? Oh yeah, the gravitation of a body that's really small. How did those other bodies know that the gravitational field of this presumably small object was even there? For instance, Earth has a very weak gravitational field. But Earth has many trillions and trillions of tons of rock and mineral and iron and you name it. So how did this small body just know exactly where to go? It's statistically, I want to do the statistics on it. I want to figure out how likely it is for hundreds of millions and billions of little particles floating about in outer space to know exactly which direction to go in to form a centralized globular ball. It's probably highly statistically improbable for this to go down just like that. What's more likely to happen is you have an object moving through outer space, and it will pass right by. It'll pass right by everything, and objects will just fly past it and not even interact with it at all. Now, the solution to these issues are It's very basic to understand here. You have two ways that you accrete matter. Number one, you have accretion outside a body, and you have accretion, number two, inside a body. Now, establishment science, they do accretion outside a body. It's statistically improbable for this to happen. There's no heat source. There's no way for all this material to come together in the center because it doesn't know where it's going. The gravitational field is too small. There's no pressure to form the rocks. There's no heat to form the rocks. All that's solved by making the accretion happen inside the stellar body. So this process happens on the inside of the star. So basically, when you see those diagrams or those graphs or those graphics videos, you name it, what you're looking at are them assuming this happens outside of the body. So in order to really get stellar metamorphosis, you have to look at that video and realize that that's happening on the interior of the star as it's cooling and dying. And the star provides all the direction for this material to travel in. The star provides the heat, the star provides the pressure, and the star provides the energy required to form the molecules to form the rocks and minerals to begin with. So, alright, I guess that's enough. Hopefully people understand what's going on here. And guys, you can take out what you want from this video. I just wanted to show this to people. Alright, later.